All right, so these are going to be what we're going to do during Zoom time. So you can be practicing these. Yeah, I'll let you practice. Some of them might you run into difficulties with. That's okay, because I'm going to help you with it, right? Don't worry. All right, so let's walk through this here. So these classical theorems. So these are good for you to be able to reproduce. So everything's written here, so you can just sit back and listen. Okay, so we're proving that root 2 is irrational. So remember, irrational doesn't have any properties, so we want to go to contradiction, and we want to say, okay, suppose not. Suppose that root 2 is rational. We know things about rational, right? So if root 2 is rational, then it can be written as a over b, with a and b integers. Oh, and this extra fact here, that a and b have no common factors. Oops, and I forgot to say b doesn't equal 0, right? If it's a rational number, b can't be 0. Okay, so a and b have no common factors. That's a big deal. We need that. So if I square both sides, I get 2 is equal to a squared over b squared. So this can be written as 2b squared is a squared. Okay, let's think about this. So here I have a squared equal to 2b squared. So doesn't that mean that a squared is even? So if a squared is even, that means a is even. And so a's got to equal 2k for k some integer. Okay, so if a is equal to 2k, I'm going to put it in there. So I get a squared is 4k squared. Okay, so I'm rewriting this. So instead of a squared, I'm putting in 4k squared, right? This is this. And then I'm carrying along my 2b squared. All right, so now I'm going to divide both sides by 2. So divide both sides by 2. So I get b squared is equal to 2k squared. Okay, so what does this mean about b squared? Since b squared, is even, right? Because it's a multiple of 2, that must mean b is even. So b is equal to 2t for some integer t. Wait a minute. I just showed that a and b were both even. What did I say here? Oh, they have no common factors. If they're both even, they would both have the number 2 in common. So that contradicts the supposition that they have no common factors. So that means there's my contradiction. It's false. All right, so just kind of walk through another one here. So show by proof by contradiction that this is irrational. So let's suppose not. Let's suppose it is rational. So if it is rational, it can be written as a over b for a and b integers, b not equal to 0. So I'm going to solve for my root 2, right? So I'm going to subtract 1, divide by, subtract 1. I guess I did that. And then what did I do? I made common denominators, and then I divided by 3. So why would I want common denominators? I want to be able to show something's wrong. Here I have root 2 written as a quotient of integers, and I know that b doesn't equal 0, so what did I just do? I just showed that root 2 was rational. That's not true because I know that root 2 is irrational, so therefore it's false.